I did it. Okay. So I was quite disheartened at the end of the last video. But I've managed to solve it. I realized it was a really stupid thing, as I said. It was something I was doing that was really dumb but really easy to miss. So this line here, I was saying if x does not equal column and y does not equal row. But that wasn't quite what I wanted it to do, because as soon as x didn't equal column, this was failing. But that's not what I wanted to do. I was wanting to check if x is equal. So if x and y are equal to column and row, then I wanted to pass. Okay, I just didn't want to do anything. If they weren't equal to that, then I wanted to add to my occupied seats. And that's where I was going wrong. I just had the expression round the wrong way, and it wasn't doing what I wanted it to do. And I just phrased it a little bit badly. Now, if I run this, so I've got I've been testing it with a lot more data. Let's comment this out, and let's put part 1 back in. If I run this, okay, I'm still printing out loads of garbage to the thing, but I get 37, which is the magic number from here. So if we jump back into REPL.it, where am I printing seating plan? Let's get rid of this, get rid of that, and hit run. Day 11, part 1, 37. Okay, fantastic. So I've got this is working. So now I'm going to use my real data and hopefully solve day 11. So let's say puzzle data is equal to helper.read file. Going to be in the 2020 folder, day 11 data.txt, and we are going to use that as our input. So down here, I'm going to say part 1 with my puzzle data, and let's see if we get an actual result. I haven't tested this yet. Maybe I should have. But I've got faith now. I've got faith. It's working. I'm sure it's just the server being slow right now. I'm sure that's all this delay is. Sure, there's nothing else wrong. Just waiting for the server. Just waiting for the internet. Sure, that's all we're waiting for. 2,316. Now that sounds a bit more like an advent of code answer. Let's have a look and see. 2316, is that correct? 2316, yeah, okay. Here we go. Deep breath. Most magic box on the internet. Will I get it right? Yes, we did it. We did it. It was so painful. There was like half an hour of unnecessary chaff in the last video, which I do apologize for, but we have done it, which is the main thing. We got there. We persevered. We didn't let it beat us, and we've got it. Now, can we do day 2? That's the question. As soon as people start to arrive, you realize your mistake. People don't just care about adjacent seats. They care about the first seat they can see in each of those 8 directions. Oh, God. Now, instead of considering just the 8 immediately adjacent seats, consider the first seat in each of those 8 directions. For example, the empty seat below would see 8 occupied seats. Okay, so it's the first seat it sees from these. The leftmost empty seat below would only see 1 empty seat, but cannot see any of the occupied seats. So this one here can only see an empty seat. It can't see any occupied seats. The empty seat below would see no occupied seats. So it looks up here, it just sees dots. It looks to the left, dots, right, dots, and it looks down and it just sees dots. Also, people seem to be more tolerant than you expected. It now takes 5 or more visible occupied seats for an occupied seat to become empty, rather than 4 or more from the previous rules. The other rules still apply. Empty seats that see no occupied seats become occupied, seats matching no rules don't change, and floor never changes. Given the same starting layout as above, these new rules cause the seating area to shift around as follows. Okay, so that does all of that. Again, at this point, people stop shifting around and the seating area reaches equilibrium. Once this occurs, you count 26 occupied seats. Okay, so we need to just change the way that we are looking at occupied seats. I'm pretty sure we just need to, dare I say it, just add one function and we should be good to go. Yeah, yeah. Okay, so we are going to make a function. So we're checking adjacent seats. We're checking an adjacent seat and we're checking adjacent seats. So I'm going to say F, look for visible seats. Now, obviously give it our seating plan. And we're going to give it a row and a column. And let's just steal this for the time being. And modify this. So we're going to go through our range, but now instead of going from row -1, we're just going to go from we just want to go from where we are until we see a hash, right? So we want to go from our position, from our row, and we want to go out. And then we want to go from our row and backwards. So we kind of want to go for y in range. We want to go from wherever we've started, whatever our row is, and then we want to go all the way to the end, and we want to check to see whether we have any seats there. So we're going to go from row down to the length of seating plan. And we're going to go from the column to the length of seating plan row. So this is going to allow us to look across. So if we were to take test data here, it's going to allow us to, if we started at this position here, I'll mark it with there. That's not very helpful because it's throwing it all out of whack. But if we're here on this little, it doesn't help that it highlights them all. Let's change this to a different symbol. If we're at this hyphen, okay, we're going to check all the way to our right, and we're going to check all the way down. That's what that's going to do. But we also need to up and left. So I want a check visible seat. So def check visible seat. And I guess actually check visible seat could just take in a starting position and a direction, right? And then we could just get it to change based on that direction. Let's try that. So let's give it a seating plan. Let's give it a row, a column, and a direction. And let's say we want to go, how are we going to reduce the amount of lines of code here? We don't want a massive if statement. That's not going to be good. But I'm going to go for something like, I want to go through direction is going to affect how we go through the loop, right? So I guess we're going to have a start position. An end position. And our direction. And so we want like an increment. And so we're going to say if direction equals up, we are going to say our start position. If we want to go upwards, our start position needs to be, where does it need to be? It needs to be our column. our row. Start position needs to be our row. And our end position is going to equal 0 or -1, because we're going to go up to but not including our end position. And our increment is also going to be -1. If our direction is this is almost seeming clever, but I can see a couple of issues that are going to come up with this. If our direction is down, then our start position is going to equal row again. So maybe we don't actually need to set our start position in each of these ifs. We'll have a look at that. Our end position is going to equal the length of our row. However long that is, that's how far down we're going to go. And our increment is going to equal 1. Okay. If our direction is equal to left, if we're going left, then if we're going left, we're going to start our column, and we are going to end at -1. Oh, equals -1, and we're going to say our increment is also -1. Well, if our direction is right, then what we're going to do is we're going to say our start position is equal to column. No, our start position is equal to column. We're going to say our end position equals the length of, and I don't want to say row, I want to say seating plan, and I want to say the end position is seating plan row, so however long that is. So we're going to start there, and our increment there is going to be 1. So we can give it a row and a column, and then we can tell it to go up, we can tell it to look down, we can tell it to look left, and we can tell it to look right. Okay. Okay. So now what we want to do is we want to write a for loop, right? So we want to say for I in range, we're going to go from our start position to our end position, and we're going to use our increment. We are then going to say if our seating plan at this is really badly coded, but really I guess what I need to do is I need to check if we're going up and down or left and right as well. So if direction is equal to up or direction is equal to down, and I could put this in a function to refactor it, but I'm just kind of thinking out loud at the moment. If our seating plan, so it's the row that's changing, isn't it? So if our seating plan at position I and column, our column is going to stay the same. We're just going up and down, is equal to a hash, and we're going to return 1. Otherwise, if we get to the end of that, we're going to return 0. And then we're just going to do the same up here. So we're going to say elif direction is left, or direction is right. Then we're going to, instead of having this, we're going to keep the row the same and the column's going to change. So it's going to start at I, and it's going to go from the start position up to the end position. And if it sees a hash, it's going to return 1. If it doesn't see a hash, it's going to return 0. Okay, I feel good about this. So even though that's quite long, it makes sense. And there's no, I'm not, the trouble is when I try and write compact codes, things go wrong and it's hard to find out why. So that's my excuse anyway. Look for visible seat. So we're going to say, we're going to call check visible seat. And we're going to go for Y in range and for X in range. That's still fine. Is that fine? Row, we're going to go from row to the length of seating plan. Oh, this is, okay, yeah. So really, what do we want to do? We want to check our visible seat 4 times, right? And then that's it. Let's just check our example. So here, this L would see 8 occupied seats because it can go diagonally as well. It can go diagonally. I thought it said it didn't care about, they care about the first seat they can see in each of those 8 directions. Okay, so we also need to be thoughtful about how we're doing diagonal. So when we're checking our visible seat, we need up, down, left, right. And then we also need diagonal where we will be adding the same value to both X and Y as we go up. Okay. Okay, so let's keep this. Let's check visible seat. We're checking that, but then we need to check we're checking the, what do you call them? The cardinals. But we also need to check the diagonals. Now that's going to be a bit more of a challenge. Also, this kind of, we don't need to use this anymore. We're going to be given a row and a column, and then our check visible seat is going to use that to then go on and find it. Also, we don't want to actually check the first position where we are. So if direction is up, our start position will be row -1 because we want to start 1 up from us. We know where we are. We don't need to check that. And similarly, when we're going down, our start position is going to be row add 1. When we're going left, our column is going to be -1, and our start position is going to be add 1 if we're going right. So this should do the cardinals just fine. And let's just check that. Let's get rid of all of this. And let's put in our directions. So let's say directions equals up, down, left, and right. And then we can say for direction in directions, we're going to say occupied seats plus equals check visible seat. We're going to give it the seating plan. We're going to give it the row that we've been given, the column that we've been given, and we're also going to give it our direction. Now I'm just going to test this function here. So look for visible seats. So let's comment this out. Ooh. Let's comment this out. And we're going to say look for visible seats. And we're going to use this very specific data here. So this one here should see no occupied seats. And then we can update this as well to kind of just check that it's working. So if I come up here, here, that. What should we call this? Let's say visible data. It's a bad name. Visible data equals this. Okay, lovely. And down here, what we're going to do is we're going to say, look for visible seats. We're going to give it visible data, and we want the thing, we're going to give it this position here. So it's going to be row 0, 1, 2, 3, and it's going to be column 0, 1, 2, 3. So it's going to be 3, 3, and that should be happy then. 3, 3. Look for visible seats. And does this do anything? It returns occupied seats. So I'm going to say print look for visible seats. Now, if this is working, it should return 0 or or not defined. Let's I copied that. I didn't copy it properly. Okay, it returns 0. Lovely. Now, if I pop a hash here and a hash here, it should return just 1. Good, fantastic. If I put 2 hashes here, it should return 2. If I put a hash here, it should return 3. So this should return 3. Fantastic. And if I get rid of this hash with a dot, it should still return 3. Good. This should return 4. Okay, it's working. It's great. Fantastic. So that is working. Now all we need to do is we need to write some code that will check the diagonals. So we're going to add to check visible seat. Now, I need to think of a good word for diagonal. So let's say elif direction equals, I'm just going to use like top right, bottom left, top left, bottom right. I think that'll be best for my brain. So let's say if direction equals top right, then our start position is now going to be an array. And our array is going to be our row plus 1 and our column plus 1. And do we need an end position? We're just going to keep going until one of these is too small or too large. And our increment is going to equal 1. Okay. This is almost seeming like it might be okay. Left, not left, right, top left. Top left, we are going to start at, we're going to go, hang on, top right, we want to go row -1, column +1. We're going back up to 0, and the column's getting larger. Top left, the row's still getting smaller, but the column's getting smaller as well. So our increment's not really going to cut it this time, because we need to be affecting each of these differently. So really what we need here is an X increment and a Y increment. And I don't need an end position. So actually what I'm going to do is I'm going to say X equals row going up. Wait, that's Y. X will be the column. So the column will +1. Y will be equal to the row -1. So that will go back up. And I'm just going to call it X increment will equal 1, and our Y increment will equal -1. And actually, if I'm thoughtful about this, what I can do is I can put them there, and I can say X equals column add X increment, and Y equals row add Y increment. Okay, this. And let's pop this here. So these will both be -1 now. So now all I have to do is change these increments, which makes it a little bit nicer, a little bit easier to follow. So let's copy these two and just swap out the values. So top right, we now have bottom right, and we have bottom left. And when we're going bottom right, our X is getting larger, and so is our Y. And when we're going left, our X is getting smaller, but our Y is getting larger. Okay, fantastic. So now we're going to say elif and I guess actually we're just going to put the loop straight into these. So let's just copy this for loop. Come up here. So start in top right. And we're going to go for I in, we don't really want an I. We just want to say while X is, so X is always getting bigger in this one. So while X is less than our seating plan, the length of our seating plan, and X is the column. So we want seating plan row. While X is less than that and Y is getting smaller, so Y is greater than 0, then we're going to keep doing this. So we're going to say if seating plan at Y, X equals a hash, we're going to return 1. Otherwise, we're going to say X equals column, add X increment, Y equals row, add Y. No, we're going to say X plus equals X increment, and Y plus equals Y increment. So Y will add -1 and become lower, X will add 1 and become higher. And so we'll keep checking that seating plan like that. Okay, so we can now, wait, why did I get rid of X and Y there? I didn't mean to. Why did I cut them? That was silly. Let's take that. So X plus equals X inc, and Y plus equals, Y plus equals Y inc, short for increment. We'll keep going around. Once one of those maxes out or bottoms out, then we're going to come out of this while loop and we're going to return 0. So that's fine. And then we're just going to take this. There is definitely, I'm sure you're in no doubt, but there is definitely a better way to program this than what I'm doing. But I just want it to work. That's all I want. Okay, so we've set up the X and the Y increments. So this should just work. Oh no, we just need to maybe change we need to be more thoughtful about these conditions. So X is getting smaller this time. So we want to say, well, X is greater than 0 and Y is greater than 0 or equal to. It can be equal to as well. So I'll update that here as well. And Y is greater than or equal to 0. We're going to do that. Fantastic. Okay, I've got a really good feeling about this. Maybe it's really misplaced. So while X is greater than length of seating plan row, and Y is greater than length of seating plan. We did call it seating plan. This function is out of control. And we'll pop in another while loop. So X is getting smaller. So while X is greater than or equal to 0, and Y is less than the length of our seating plan, because Y is getting larger. Get rid of this. If seating plan is that, return 1. Increase X and Y by their respective increments that we've defined there, and then we return Okay. So if it hits any of these top left, top right, it's going to return. It's never going to get down to here. If it does get down to here, it will run this. So let's add these directions into here. So we're going to have top right or top left, as the auto fill has decided. Top right. We're also going to have bottom left and bottom right. Okay. Now we've got our we just updated our directions, so we don't have to actually change anything here. So here, what we're going to do: print look for visible seats, visible data 3.3, and at the moment we've got a hash here. Let's return this. So we've got nothing, 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 and nothing. Okay, so this should give us 0. And I've forgot to get rid of that bracket when I undid earlier. So let's run that. And I've copied that. So of course that bracket's in every line down here. Let's get rid of that. And let's get rid of this. Okay, fantastic. So let's run this. And elif is missing a colon, maybe? Line 137. Oh, okay. I don't need this elif. I started writing something and then got sidetracked. So we've got 1 here. And why have we got 1? Because we've got a hash. No. Why have we got a 1? Ah, because we've got a hash there. Great, fantastic. And breathe. Okay, it's still working. So got a 0 there. But if I put a hash in this top corner, do I get a 1? Yes. And if I put a hash in this corner, do I get a 2? Yes. And if I put a hash here, does it stay a 2? Yes. It's working. It's working. It's working. It's working. Okay, fantastic. So we now need to write a part 3. So we're just going to basically just copy this. Oh, the amount of code I've copied and pasted today is embarrassing. But as I say, we just want it to work. That's all I want. So part 2, changes equals 99. While changes does not equal 0, new seating plan changes, generate new seating plan. When we generate a new seating plan, we are doing all of this and we are checking adjacent seats. So what does this do? Look for visible seats. We just want to go through each row in each column, and then we just want to pass it that row and column number, right? So we can be a bit more simple with this. I guess then we're doing the logic here, aren't we? Seat equals seating plan, row column. Yeah, so what if I just did, let's call this version 1, and let's just copy this. And let's make a version 2. It's really annoying when they change the rules, because I don't want to get rid of my old code, but it just feels wrong to do that. Okay, we take copy, we've got change at 0, we're going through every row, through every column, and we are finding our occupied neighbors by saying check visible seats, look for visible seats. Nice naming convention there. Okay, look for visible seats, and we're giving it a seating plan, a row, and a column. Good. Seat equals seating plan at row and column. If our seat is L and our occupied neighbors is 0, however, they've changed one of the rules here, haven't they? It now takes 5 or more. So we're going to update this to be an occupied neighbors is greater than or equal to 5. Okay, so with our test data, what answer did we get? So they ran this, they got this, and they had 26 occupied seats. So with part 2, if I change this to day 11, part 2, answer, generate new seating plan, version 2, and let's update part 1 to use version 1. I don't remember updating version 2 to say version 2. Oh, I did. Great. Okay. So this is all fine, right? This is great. This is lovely. This is fantastic. I think. Yeah, this is all. This is just going to run fine. Why wouldn't it? Why wouldn't it? So let's say part 2. We're going to give it our test data, and we're going to cross our fingers, and we're gonna pray to the lords of programming, the great Python overlords. And we wanted 26. Oh no, I've done something daft again, haven't I? No doubt. I think it's all this copying and pasting. It cannot be good. So we've got part 2 here. We're going, while our changes do not equal 0, we're generating a new seating plan and our amount of changes. So here our changes equal 0. We take a copy of our seating plan and we go through each row and each column in our seating plan. We look for our visible seats. That's our occupied neighbors. Are we actually occupied seats plus equals check visible seat, and check visible seat will return 1 if it's working, 0 if yeah, because it did work on our test data, didn't it? So that's all good. Okay, so that's fine. So then we're saying occupied seats plus equals check visible seat with a row, a column, and a direction. So we're checking all directions with that row and that column, and we're adding all the occupied seats that we find to a maximum possible of 8. And then we're going to return those occupied seats. Okay, so once we've done that, we then get our seat and we check it. So if our seat is an L and we have 0 occupied neighbors, let's just check the rule on that. Let's just check the rule. The first seat, they care about the first seat. Yeah, that's what we're handling. No, instead of considering, so the first seat in each of these 8 directions. Yep, that's fine. That's fine. That's fine. Rather than for the other rules still apply. Empty seats that see no occupied seats become occupied. Seats matching no rule don't change. And floor never changes. Okay. I did give it test data, right? And I haven't messed around with this. That's fine. And I'm passing in test data there. Yeah, okay. So we're saying generate new seating plan version 2. So if it's L and occupied neighbors equals 0, we're then saying our new seating plan at row, we're just updating that to a hash or an L. So that all is just the same. That's all fine. Is there some kind of weird sum we have to do at the end? People start something out. Let's see. Once this occurs, you count 26 occupied seats. Am I printing out occupied seats here? Yeah, answer equals count occupied seats, new seating plan. And then we're printing out the answer. So it's saying there's 15 occupied seats there. So let's also print seating plan and give it our new seating plan, just to check that it's working properly. So we end up with this. Is that what this kind of looks like? No, there's a lot more in the middle, or is there? Are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, yeah. So that is counting them. They're just wrong. And I think it's when we're looking for visible seats. Check visible seat. Look for visible seats. No, so when we're checking our visible seat down here, we're checking all of them and we're only returning 1 if we find an occupied one. Otherwise, we wait until the end and then we're returning 0. Is there anywhere? The direction has to be up, down, left, right, top, right. I've made sure of that. So it is only going to hit one of these functions. one of these if statements, and then this is going to hit, and that's all going to be fine. This all tracks. Have I got my directions correct? I believe so, because I did test the data. But let's just double check. So top right, we're going across and back. Yep. Top left, we're going back and back. Yep. Bottom right, we're going down and across. Yep. And bottom left, we're going back and down. That's fine. Okay, so the increments are fine. Are these Boolean expressions correct? I think so. X is less than that. Yeah. Y is less than that. Y is less than that. And it was working with this when we were just playing around with it a little bit. But when we're getting further iterations, it's not working. So we should be getting 26, but we're getting 15. And it has to be greater than 5, right? Now it takes 5 or more visible occupied seats for an occupied seat to become empty. For an occupied seat to become empty. So if I left this at 4, give me 12. Okay. If I make this 5 or more, I get 15. And the answer is count of the occupied seats. With my new seating plan. It's going to be another stupid if problem, isn't it? Isn't it? Yeah. So it's got to be here because the logic here is sound. It's doing. We've only had to update really this rule here. It's still this rule hasn't changed. If the seat is an L and there are no occupied neighbors, then we update it to a hash and we log that we've changed something. If it's a hash and we have more than 5 occupied neighbors, then we're doing this. But the way we're counting occupied neighbors must just be slightly wrong. So if we come up to our occupied neighbor, I'll look for visible seats and I'll check visible seat. So we're saying our occupied seats equals 0. We've got these different directions. We're going through each direction and we're adding to our occupied seats. Checking the visible seat with the row and the column that we've been given, plus the direction that we want it to travel in. And we're going to check each direction. So check visible seat. If direction equals up, start position equals row -1, end position equals -1, increment equals -1. Am I doing any checks here to stop them going out of bounds? Well, I've solved day one. I'm going to have to spend some more time looking at this. I think I need to sleep on it. It's getting harder. It's getting much harder. I really like the style of these puzzles, but they are difficult. Let's try and just group this in a bit more of a thoughtful way. So these are kind of little helper functions. Yeah, that should at least make it a little bit more clear. So we've got our part 1 functions. We can get rid of these rules because they're for part 1, which are not relevant anymore. And then we've got our part 2 functions here. And then let's just take part 1. And we will pop it up here. And I really do want to solve this. It's not going to happen this evening. So I'm going to try tomorrow, see if I can solve this. I'm really glad we got part 1 done, though, because I really thought that had finished me off. But we live to code another day. Hopefully some of this has been helpful or enjoyable. I'm going to go get some sleep. Thanks for watching, and I will see you maybe in tomorrow's one, if it doesn't absolutely destroy me.